Okay, listen. Today we are going to discuss about the electromagnetic waves, that is the unit 5. In that we are going to discuss about the electromagnetic wave equations. So the electromagnetic wave equation, it's have many categories. So in the first wave equations we are considered for the conducting medium. In that you need to find the wave equation for the electric field as well as the magnetic field. So the electric field, in the sense, you need to consider the two laws from the Maxwell's equation. So the second equation, that is the Maxwell's equation from the Faraday's law, and Maxwell equation from the Ampere's law. That was the first Maxwell's equation, and the second equation you should consider. Initially, you can derive the equations or obtain the equation from the waves, electromagnetic wave equation from the Maxwell's equation. So you should remember the Maxwell equation. All four equations you should remember. So initially, the Faraday's laws of Maxwell equation you should consider in the point form. That is the del cross E, it should be equal to minus dou B by dou T. So the minus mu into dou H by dou T. That is the formula. That is the equation. That is the Maxwell equation from the point form. So you can consider the equation 1, and you can take the curl on both sides, del cross E, and again the LHS side also you can take the curl. So the final equation become like that. The del cross E, it should be equal to minus mu into del cross dou H by dou T. So here you can consider the Maxwell's first equation from the Ampere's law, that is the del cross H. So the del cross H, it should be equal to sigma into E plus epsilon into dou E by dou T. That was the actual expression we taken from the Ampere's law. So here you can differentiate both the side to obtain the dou H, because the equation 2 we have dou H by dou T. So you need to make the differentiation. There is a partial differentiation in the both in the LHS side. So the dou H by dou T. So that is the, if you are already the curl is there, so the dou into del cross H divided by dou T. So del cross H value already we know. So you can substitute it and you can find the expression del cross dou H by dou T, because it is need for our previous expression. We need for this one, the del cross dou H by dou T. So we obtained this expression. Here the differentiation you can consider in the both the element. So the sigma into dou E by dou T plus epsilon into dou square E by dou T may come, right? So hereafter you can substitute the equation 3 into equation 2. The equation becomes the minus mu into, instead of del cross dou H by dou T, you can substitute this expression and you can find the final expression minus mu into sigma dou E by dou T minus mu into epsilon into dou square E by dou T square. We know the relationship, that is the del cross E. It is the identity we already derived or proved. So the del into del dot E minus del square E, that was the actual expression. But in the electric field, the del dot E and the del dot D, that is the electric field intensity and electric flux density, both are, it is the 0. That is the divergence of the electric flux density and electric field intensity becomes 0. So that is why if you are put 0, here the entire term is getting 0. So minus del square E alone, instead of del cross E, you can write minus del square E alone, because this term it is getting 0 and remaining term alone it will come, that you can write it. So here in the LHS side, as it is what you have obtained, you can write it here again. So you can eliminate the negative sign in the both the RHS and LHS side. So you can find the del square E into del square E, that is the mu, that is commonly there, you can take it commonly, and sigma into dou E by dou T plus epsilon into dou square E by dou T square. That was the actual electromagnetic wave equation in electric field. Similarly, the magnetic field also there, that we can derive from this two laws. You see here, here the Faraday's law we consider initially. Here del cross E is there, right? Del cross E is there. Then you can obtained for del cross E, right? So while you here it is the E term is there, at the end you find it the del square E, that is the electromagnetic wave equation in electric field. Similarly, you can find the del square H. Okay, the del square H you need to find, that is the electromagnetic wave equation in magnetic field, right? if you are del square h, if you need to consider the Maxwell's first equation del square h, and you can take the curl on both the side, and you can find the del square h, sorry, del e. Similarly, then you can substitute at the end, you can find from these two law. Okay, that will derive now. Okay, up to this you clear. The del square E, that is the electromagnetic wave equation in electric field. Similarly, we need to obtain the electromagnetic wave equation in magnetic field. That will derive now. Okay.